so lesson 54 is still pairs, it's still solving trig equations in trigonometry. So the sum will say solve for x. That's the least I can say. Usually they say find the general solution, that's nice of them. Or find the solution for this thing if, and then they give you an interval, so that would mean a specific solution. Alright. So how many types are there? 4, of which you at the moment know 3. This is type 3, and I'll explain to you that type 2 and 3 are basically, you can let them fall under the same thing, you're going to know what the difference is. One of them is where you've got sin and cos on either side of the equation sign, so that's going to be my first step to say equal to. Right? And then we are going to take both of them to cos. The reasoning is, if both of them are sin and cos, and the angles are not the same, there's a different version. If the angles are the same, there's another method. If the angles are the same, you divide by cos, it becomes tan. If the angles are not the same, the only way is, you've got to make them both cos. How do we make sin into cos? 90 minus the whole thing. Now guys, it can save you time if you do the following. What have I done? I've done the little brackets and I've already timed it in. So instead of saying minus and the whole bracket there, I've already said minus and minus. I'm saving myself some time. But if you're going to make mistakes, please don't do it that way. That means, and I'm not doing anything on the left hand, cos 2x equals cos. And then I can simplify. Somebody showed me yesterday they kept it that way, no problem. As long as at the end it's simplified, it's fine. But you can add and get 60 minus x, right? Somebody wrote minus x plus 60, no problem. Then, this is the one that you don't go reference angle, and which quadrants am I? You only make a logical deduction. Look at this equation. They look the same with causes on both sides, so the angles must be equal to each other. So we have 2x equal to, and then that angle on the other side. Is that right? No, it's wrong. Until I add the plus minus plus k times 3 to 16. Now I've added all the possibilities. So you make a logical deduction, you put a plus minus in front of that one. I explained to you why yesterday, I'm not going to go into that every day. Then we've got our answers. Now there's 2 ways of doing it. We are, well, not 2 ways of doing it, there are 2 answers here. So we've got 2x equal to 60 minus x plus k 360. That's when I take the plus option. Or, if I take the minus option, I write down 2x is equal to negative. Now can I save time again? By immediately saying negative and plus. If you first want to write the minus with the bracket and then in the second step do this, it's fine. But you're trying to save time wherever you can. So I'm already applying the minus in, so it's minus 60 and plus x. Still plus the k360. Now we've got to solve a normal algebra equation. Get the x's to one side because this is what I'm trying to solve, is for x. So we've got x added on this side will be 3x. Agreed? Yes. Then we divide by 3 and we divide by 3. Divide by 3 gives me 120. Finish. This is a general solution, but this is only half the answers. The other half of the answers sit here. When I take the x and it becomes a minus x, I've got x equal to negative 60 plus k 360, and I'm done. Done, done, done? No? Yes. Because remember what this means is, the answers are 20 plus 0, 1, 2, 3, 4, 5 times 20 and minus 1 minus 2 times 120. And when you actually do the specific solution, and I say, get me the specific solution in this interval, you start off with 20 and you plus 120, plus 120, plus 120, plus 120 until you can't go further, and minus 120, minus 120 until you can't go further. Remember the other thing that I taught you? If your answers look a little different than an exam aid memo or any memo from anywhere, how will you know if your answers are the same? Because they look totally different. How will you know that your answers are the same? Get a specific solution for yourself from, say, minus 180 to plus 180 or 270 to minus 270. Look at yours, look at theirs, and that's not the same. Then you have made a mistake somewhere. Then you must ask me if you can't find a mistake. All right. So today is the type 4. Type 4 is when you have something like the following. Alright, now you didn't know about type 4 until today, so you still don't know about type 4, I mentioned it. Type 4 is where you're going to factorize. Why is this not type 1? Obvious reasons. It's not just sin or cosine equal to a ratio. Type 2 and 3, well, they're both sin. So can't I just say x is x? Oh, there's a square. Make a logical deduction. Are you hearing me throwing around nonsense ideas here? But now type 4, there's also still 2 terms like there was there, but not one sin and one cos. If the one was sin and one was cos, different story. Type 4, it has to then be, so I go through all the motions. Type 1, no, type 2, no, type 3, no. But type 4 is where you are going to factorize. How many factorizations do you know? 5. First of all, common factor. And usually that's what they ask if it's a nice level 1 or 2 sum. But in general, KES is never level 1. KES always is level 2. But it gets worse the worse these type 4s go. The worse the factorization go. But this one, if you factorize, what's my first principle? You always get it equal to? 0. Ah, excellent. And then, what type is the first type of factorization? Common factor. You take out a comma? 6. And that's that. But there can be difference of squares. There can be a trinomial. We're going to do that. How do you think is a good idea to do a trinomial when I give it to you for homework? K method, exactly. If it was something like 2 sin squared plus, no, I'm definitely going to give you something that doesn't work at the moment. Can you see it being a K method sum? If it was 2k squared plus k minus 1, then you nicely factorize. And after a while, you're not going to need that. You're going to be able to do it anyway. Most of you. Okay. That's the trinomial. Can I get grouping?
Yes.
It's going to be rough, but you can. So at least you have to have 4 terms to be able to group. So it can't be grouping. There's only 2 terms. And then difference of cubes and sum of cubes?
No.
I haven't seen that they do that in Trig, because you can see the nature of it isn't going to fall into our syllabus. Alright. But there are 5 types of factorization. If I do factorize, then I'm going to have left sin x minus 1. And my 2 answers are going to be, or sin x is equal to, what's this? Type 1. Oh, back to type 1. So we're practicing type 1 all the time, but we never go back to type 1 in that type. Okay, so let's do the sum. If I'm at this question at this stage, then my routine is first get the reference angle. I'm just going to erase this bit here. So I've got more space. In this case, for sin x equal to 0, what is my reference angle?
0.
Are you sure?
Yes.
Yes, think about the graphs. Where is sin 0 at 0? Happiness?
Yes.
Then we're going to go and say, now here's the trick question. Well, it's not really a trick. But in which quadrant am I? Is sin positive or is sin negative?
No. Positive. Like, no.
I always say it depends on how you feel about having no money. 0 in my bank. Do I feel positive about it or negative about it?
Negative.
Okay. The arrangement is, let's feel positive about 0. Because you don't know if it's positive or negative. What is 0? So now, we are making an arrangement here, but man, you can't just do that. No, I can't. But I have a reason why. I'm going to say that, but Josh feels very negative about his negative the zero account. Please go and check me on this because we don't have time. If you do it that way and you write down your general solution and you look at my general solution, they're the same.
Oh.
Okay, so this is the arrangement we have in general in maths. We're going to say if it's zero, let's feel positive about it. So sin is positive in the first and the second quadrant. Are you with me?
Yes,
Please
ma'am.
do me the favor and go check it out for quadrant 3 and 4 and see what the answers look like, and trust me, it's going to be the same. Okay. So then, writing it in quadrant 1 will mean, what do I write first? The
Name of the angle.
now, excellent. Name of the angle is x. And for that one, we'll just write 0, right?
Yes.
Plus
K times
k
360.
360. For quadrant 2, what are we going to write?
It's
180 minus 0 plus k 360. Now I'm wasting some time, but let's do it. So it's just 180 plus k 360. Are you happy on that? That's it. Not quite, ma'am. I still have to do that. Oh no. 2 answers here, 2 answers there. So you've got to space yourself a little bit or use more space at the bottom. Reference angle. How do I know that? Just like that. Because I know my graphs. Right? Reference angle is 90 and I'm in the positive, first and second. Again, first quadrant the name is x and it's 90 plus k 360. And for quadrant number 2, 180 minus 90 plus k 360. Look what happens here. Just by accident. Oh, it's one of those sums that I say x is 3 or x is 3. Same thing. Are you with me? And the only thing I mustn't forget is and then you've got full marks. Now, in the exam aid, the answer oh man, what now? Now if you can do this, it's fine, but please don't stress your brain to go and get this. But look at these answers. There's 0 and you add 360 all the time. And it's 180 and you add 360 all the time. Can't those two just be 180 plus 360 all the time? Or just 0 plus 180? Plus 180. If you plus it with 180, you're going to get there and get back here and get back there. But if you put the 90s all in the middle of them, it's going to be 90. And if I've lost you, it's okay. But how will I know that their answer that just says k, what's going on here? Nothing. I'm just saying k times 90. So I'm going to start with k is 0, so it's 0. Then it's going to be 90, 180, 90, 180, 270 will come out here as well. Are you with me, guys? It will be the same thing. Not so that you can understand it, please. If you don't, tough. Doesn't matter. Okay? If you don't understand it, tough. I'm just stressing that if the exam aid says an answer and yours doesn't look the same, it's because they were trying to be cute. And now they've lost you. Just look at their answer specific solution and your answer specific solution and you're 100%. Please don't even try what I just did there. Don't. You're wasting time. That is perfect. Why waste time? Finish. Okay. Tell me quickly, what time is this? Type 4. You're going to take out a common 10. Very often with the factorizations, it's a common factor. What are you going to do here?
Cos over.
Capital and make both cos.
What do you do with sin?
Sin
Sin over cos. And then I cancel the cos. Oh, God is cos. No, cos was there. And it couldn't be 0 if it was at the bottom. So you're allowed to cancel it out. And then you're going to have, what is it, sin, which is type 1. I'm helping you because you're new in this. Right? This is type 2 or 3. Which one? I don't know. It's the one with the angles are the same. So we divide by cos. to make it 10. This one? Type 4, because you're going to factorize, there are 3 terms. Okay, it's going to still get worse, guys, and we don't have time to practice and practice to get to the worst of the worst. You've got to practice on your own. Am I saying it enough?
Yes.
If you don't go and practice a heap more of this, you're not ready. Can I not substitute 1 with sin squared plus cos squared at some stage if necessary? Then I hope you've got a plan. If you do it, there's got to come something from it. Because in trig, at any stage, can I not substitute 1 with sin squared plus cos squared? I'm mentioning it for another sum. Okay, if it comes.